Hi, I'm Dr. Christopher Sutton. Welcome to my Introduction to GIS video series. In this video, I will cover how to modify map projections using GIS software. For this video, I will use the ArcGIS Pro desktop software, although the techniques applied here can be done in other software packages. In ArcGIS Pro, you apply a map projection using the Coordinate Systems tab of the map properties. Map projections are listed in the Projected Coordinate System section. Let's expand the Continental and then North America sections to view all the various custom map projections that are available for mapping North America. Let's examine the North America Albers Equal Area Conic projection and look at its parameters. We can see that the central meridian is set to minus 96 degrees, or 96 degrees west. The latitude of origin is 40 degrees north, and the standard parallels are set to 20 degrees and 60 degrees north. Recall from an earlier video that if you see two standard lines, the projection case is secant. Oftentimes you will find yourself in a situation where there isn't a prepackaged map projection that works best for the area you are mapping. For example, you might be making a map of a study area comprised of counties in eastern Illinois and western Indiana. If you apply one of these custom projections, the resulting map will look odd. Let's apply the North America Albers Equal Area Conic projection to the map. Note how the counties are rotated counterclockwise. The reason for this is that the custom parameters used in the North America Albers projection are set to work for all of North America, not the study area. Let's customize the Albers projection to work for the study area counties. Because the Albers Equal Area Conic projection is a secant projection, there are 4 parameters to adjust to best fit the projection to the study area. The first is the central meridian. The central meridian, which in some projections is called the longitude of origin, is the longitude line in the center of the map projection. When specifying a central meridian, you should use the longitude that bisects the mapped area. As noted earlier, the central meridian value of the North America Albers Equal Area Conic projection is 96 degrees west, which passes through Nebraska, Kansas, and Oklahoma. This is approximately 400 miles west of the area being mapped. Let's return to the Coordinate Systems tab to adjust the properties of the North American Albers Equal Area Conic projection to work for our study area counties. To customize a projection, right-click on it and select Copy and Modify from the context menu. In the dialog that appears, enter values appropriate for the area being mapped. In the case of our study area counties, I will change the central meridian value to minus 87.5. I will keep the latitude of origin at 40 degrees because it passes through the middle of my study area. I will change the standard parallel values to 39.5 and to 40.5. You can even change the name of the projection to something appropriate for the mapped area. Click Save to register the changes, and then OK. If we return to the study area, we'll see that the counties are no longer rotated counterclockwise. ArcGIS Pro has another way to assign a custom map projection that does not involve modifying an existing projection. Back in the Coordinate Systems dialog, click the Add Coordinate System dropdown and select New Suggested Projected Coordinate System. In the dialog that appears, click the layer that you want to have the projection focused on. In the case of my map, it's called Study Area. Next, I will select a projection property. For this map, I want the angles to be consistent, so I will choose a conformal projection. The software comes up with a recommended conformal projection, in this case a transverse Mercator projection with a central meridian of -87.55 and a latitude of origin of 39.93. Click Save and then OK to apply the projection to the map. In the next video, I will wrap up our introduction to map projections by providing some suggestions for projections to use when mapping various locations on Earth.